Picture an internal enterprise application used by a mid-sized company. It's a tool that everyone in the company relies on, from regular employees checking their schedules to administrators managing sensitive company-wide settings. To keep things in order, the application uses role-based access control, in short, RBAC, which is supposed to restrict certain actions to specific roles. For example, administrators can edit critical settings while regular employees just don't have the clearance. However, there is a flaw. Imagine a curious employee, let's call him Alex, who's just tinkering around the application one day. Alex knows that he's just a regular employee, user with limited access. But as he's exploring, he notices something strange. He wonders, what if I try accessing an admin page directly by typing its URL in the URL bar? So, with a sense of mischief and curiosity, Alex types in https://intranet.example.com/admin/settings. Now, you would expect the system to stop him, right? But shockingly, the page loads. No error message, no login prompt, asking for admin credentials, nothing. It's as if Alex just walked into the restricted area of a high security building because someone forgot to lock the door. Now, in this scenario, the system has failed at a very basic level. It did not enforce role verification. Alex, with no malicious intent, suddenly has the power to change company-wide settings. Imagine if someone less innocent found this loophole, someone who wanted to cause harm. They could disrupt the operations or expose sensitive information. If you explore applications to find bugs, you might have come across those enterprise applications where you can invite other users. Now, you are the admin and you are the only one who can invite other users. But similar to this scenario, if a normal user can access admin functions to invite other users, even though he or she does not have permission to, then it's also the case of missing authorization. Let's talk about another example. Imagine you're an attacker browsing the store, just like any regular user. But instead of just buying items, you decide to poke around a bit. You notice that when you click to edit your order, the URL looks something like this: https://store.example.com/order/1234. It's a numerical ID /edit. Now from this URL, you can imagine, okay, this ID is used to fetch order for a particular user, and this ID is the identifier. The order ID is right there in plain sight. Now a thought crosses your mind. What if I change the order ID to another number? Will it still let me edit the order? You try it out. You swap 1234 with 5678, hoping to see if it belongs to someone else. You hit enter, and to your surprise, the page loads. Not just any page, it's another customer's order laid out for you to see and edit. You're not just viewing it, you have the power to make changes. You could change the shipping address, swap items, cancel the order, or even redirect it to yourself. That's crazy. This isn't just a glitch, it's a serious security lapse. The application is missing a crucial step. It does not verify that the user is trying to modify an order is actually the one who placed it. It's like a store that lets anyone grab another customer's package off the shelf and make changes to it. No questions asked. All you needed was right order ID, and the system simply assumed you belonged there. Now, if you are testing this in a real application, you don't know the order ID of other user, right? And you would not want to brute force right away to test out this vulnerability. In that case, you would create 2 accounts, and then you would try to see the order ID for each of those accounts. To test this, you can replace the author ID of account A with account B author ID. And if you're seeing it in the response, then yes, you found a bug. Missing authorization again. Literally anything, any function in the application that shouldn't be exposed to other user is a missing authorization vulnerability, also known as CWE 862. The last example we just looked at, it can also be called insecure direct object reference, or IDOR, which comes in the category of missing authorization itself. And the first scenario where you could see the admin functions which you shouldn't be able to just by modifying the URL. It can also be called as bypassing role-based access control, which comes in the category of missing authorization. In simple words, if you're able to perform an action or access a resource that you shouldn't be able to, or you need higher permission to do that, comes in the category of missing authorization. But now the question arises, how missing authorization even occurs? Missing authorization happens when an application does not properly check if a user has the right permissions to access certain features or data. This vulnerability can be introduced during the development process if the developer forgot to include these checks or if the checks are not applied correctly. This CWE comes in broken access control, which is one of the OS top 10 vulnerability. And throughout the episodes, we are going to look at some other CWEs which comes in the category of broken access control itself. Hope you enjoyed listening to episode 1 of this podcast, Snake Bytes. I'll keep the rest of the talk for episode 2. And if you have any questions, you can ask it in the comment below.